All right, let's talk about a huge, and I mean huge, security blind spot. We all spend a ton of time thinking about our firewalls, but what about the attacks that happen after someone gets past them? How do you catch something like a SQL injection attack while it's happening in real time right inside your database? Well, that's the exact problem AWS GuardDuty RDS Protection was built to solve, and we're going to break down exactly how it gives you eyes inside the database.
So here's our game plan for this training. First, we'll talk about the unwatched database, why it's the real target. Then we'll introduce a new kind of guard built for the job. We'll peek under the hood to see how the detection works, and then we'll get into the practical stuff, decoding the findings so you know what the alerts mean, and we'll wrap it all up with your action and response plan so you know exactly what to do.
Okay, so first up, the unwatched database. Let's really set the stage here. When an attacker gets into your cloud environment, what are they really after? It's not your EC2 instances, right? No, they are going for the prize. And that prize is always, always your data.
And this quote, this just hits the nail right on the head. For years, the most damaging attacks haven't been some super sophisticated Mission Impossible style hack. They've worked because of one simple, embarrassing fact. Nobody was actually watching the database itself. We build these giant walls around the castle, but we leave the treasure room door wide open. So, what even is a SQL injection? Honestly, at its heart, it's a devastatingly simple trick. An attacker sticks some specially crafted text, like that classic R or 1 equals 1, into a web form. If the application isn't smart enough to catch it, the database gets confused and just runs that text as a command. And boom, the database basically tells itself, hey, this login is totally valid, and the attacker just waltzes right in.
And this is where the real security gap shows up. Our usual tools, WAFs, security groups, they're all about perimeter security. They're like the guards at the front gate. They're great at protecting the path to the database. But what if the attacker is already inside the walls? What if they came from a compromised server inside your VPC? Your WAF is completely blind to that. It has no idea what SQL is actually being executed. That's where internal monitoring flips the script. It watches what happens inside the path.
And that, of course, brings us to the solution we're looking at today. It's a whole new kind of guard, designed specifically for this critical blind spot.
Now, if you remember one thing, let it be this. GuardDuty RDS Protection is not just another firewall. It is the very first native AWS service that is literally inside the room with your data. It watches every single query after a connection is made. It's designed to see what everyone else misses.
So you're probably wondering, how does it actually pull this off? It's not just looking for simple keywords. Under the hood, this is a pretty sophisticated system that uses two very distinct methods to spot threats.
First, it uses machine learning for login anomaly detection. It spends time learning what normal looks like for you, who logs in, from where, at what times. As soon as it sees something that breaks that pattern, it raises a flag. Think of it as catching brute force attacks. Second, and this is the real game changer, it analyzes a live feed of your database's activity. It is reading every single SQL statement, looking for the telltale syntax of an injection attack. And the way it gets that live feed is actually pretty brilliant. It's a simple three-step flow. A query runs on your Aurora database. Immediately, a record of that query gets fired off to a secure, encrypted Kinesis data stream. You can just think of this as a high-speed, secure conveyor belt. And GuardDuty is sitting right there at the end of the belt, inspecting everything that comes through in near real time.
Okay, so detection is great, but an alert is useless if you don't know what it means or what to do about it. So now we get to the really critical part of this training, turning those alerts or findings into actual insight you can act on. Let's break down what you'll see. Let's start with a big one. You see this finding, anomalous behavior, successful login, and the severity is high. What this means is someone successfully logged into your database from an IP or in a way that the machine learning has never seen before. You have to treat this as an active account compromise. This isn't a maybe check it later alert. This is a drop everything you're doing right now alert. Okay, this is the one nobody ever wants to see. Potential SQL injection, successful login. If you see this high-severity alert, GuardDuty is basically screaming that someone has an active session and is running queries that look like a SQL injection attack. The attacker is in, they are live, they are actively trying to steal your data right now. This is a code red, all-hands-on-deck emergency.
Now for a medium severity finding. This one is your early warning system. It's not just a single failed login, it's a whole pattern of failed logins, all coming from a source that's outside your normal baseline.
This is the classic signature of a brute force or credential stuffing attack that's trying to hammer down your door. And this is where GuardDuty gets really smart. It sees suspicious queries that look like SQL injection, and it connects the dots. It knows that these queries are coming from the same session that was just trying to brute force its way in a minute ago. It correlates those two events. That context is what turns random noise into a super strong signal that an attacker is testing their attack methods.
Now don't let the word informational on this one fool you. This finding means your database is exposed to the public internet. This is almost always a critical misconfiguration. It's a huge, flashing red light on your dashboard that needs to be fixed immediately, no matter what the severity label says.
So we know how to spot the threats, we know what the alerts mean. Now for the most important part. How do we turn all this detection into actual defense? Let's walk through the exact steps to get this service running and build out your response plan. Getting this turned on is surprisingly easy. It's just 5 steps. First, make sure the main GuardDuty service is on. Second, you have to enable database activity streams on your Aurora cluster. Just a heads up, this does require a quick restart, so plan for that. Third, you just pop into the GuardDuty console and flip the switch for RDS Protection. Fourth, and this is absolutely critical, use Event Bridge to automatically send those high-severity alerts to your on-call team's pager. And fifth, just be patient. Give the ML about 2 weeks to learn what normal looks like.
So the alarm goes off. It's a high-severity finding. What's your playbook? Here are your first 3 moves. Number 1, isolate. Don't terminate the session. Your first instinct is to kill it, but don't. Instead, use a security group to block the attacker's IP. This traps them and lets you see what they were doing. Number 2, investigate. Go pull the activity stream logs. Find out exactly what commands they ran. And number 3, rotate credentials. The user account they got in with is compromised. Rotate those keys immediately. Now, it's super important to know the limits of any tool. This is powerful, but it's not a silver bullet. So keep this in mind. Right now, that deep SQL analysis only works on Aurora databases, not standard RDS for MySQL or Postgres. It also has a tough time with what we call second-order injection, where bad data is stored now and then executed way later. And finally, remember that this is a detection layer, not a prevention layer. It's an essential complement to, not a replacement for, secure coding practices.
So let's bring it all home. Perimeter defenses are essential. You absolutely need them, but they are not enough. The most valuable thing you own, the asset that attackers truly want, lives inside your database. And so that brings us back to the one question you need to go ask your teams. We all know our data is the prize, so who's actually watching it?